Over the weekend, I had a problem statement which required the use of LLMs, not a force-fitted solution. So, on a Sunday morning, I sat with my cup of coffee, spent around 2 hours, and then built a very small AI agent. And when I was done with it, I spent around 2 million input tokens, about 0.2 million output tokens, and all in all, less than $1. The complexity of this is at a beginner level. So in this video, I will take you through the problem statement, the solution, why an LLM is required for this solution, and then step through the code too. And I hope this video should also give you some ideas about small AI agents that you can build in your day-to-day life. If this is the first AI agent that you are looking at, I would still suggest go to my other video about writing your first AI agent. It will give you a lot of information about many things that we talk here, and then come back to this video. Now the problem statement. My son is in 8th grade. His school does a great job of collating all the past year question papers, be it exams or be it tests, and they put that up in a portal like this. These question papers are excellent in nature and come very handy in his exam preparations. There are a total of about 1,000 question papers and answer sheets together. This question bank is a gold mine of data. As a user, the problems I face are like this. The actual files are hidden as attachments. Sometimes they are bunched up together, but then sometimes they are all as individual files. And many a times it is difficult to find the relevant question papers and the associated answer keys. They are all over the place. I have to keep jumping around the page and keep downloading files. So now, as a user, the requirement for me is to somehow download all of these question papers, organize them correctly so that I can retrieve them easily whenever I want. So a structure something like this would be helpful for me. Subject, under that, the type of the text, the files which says the year, and whether it's a question paper or an answer key. Whenever an exam comes, I can go to that subject, go to the relevant exam, find the question paper and the answer keys of all the previous years, and this helps me a lot. Why do we need an LLM for this? Point 1, because these are all manually uploaded, there are spelling mistakes, either intentional or unintentional. Sometimes science is as general science or GS or science, sometimes different representations. So there is no consistent naming around this. If I were to not use LLM and do it only using Python, I had done it the last year, so that's why I have a very good comparison. I used quite a lot of regex. I had to write mapping from the source format to a destination format, and that mapping kept on increasing. I spent all of 2 days and mostly about 8 hours in total to arrive at a solution. But then with an AI agent, I was just done in 2 hours, right from coding from scratch to a full execution. So what is my solution? Let's download the question paper from the portal. This is a non-AI activity. Pick each file name. This is where our AI agent starts. Call the LLM. I used Qwen72b instruct on deep infra. The LLM would extract and normalize the parameter about subject, year, type of exam, type of language, it's a core subject or a language, and many things that was necessary for me to organize. I wrote a small function which could consume this and then organize the file accordingly, rename and move them accordingly, and then send the response back to the LLM once I had done with it. So now this gave me a whole AI agent, a T.A.O, a React agent. Calling the LLM, and where the LLM understands this is the thought, it would extract and normalize the parameters, and then my tool would organize it, and that's the action, and then I would send it back for the LLM for verification, and that's the observation. So at the end of it, I was left with a T.A.O React agent. Because it's a one-time agent, I run it, downloads, organizes. I don't intend to run it a second time until the next year question bank comes in. So I didn't go overboard with the solution. I didn't over-engineer the solution. Just did as much that would help me solve this problem. Now let us dive into the code and see it working. This is my IDE. What worked to my advantage is that the files were all statically mentioned in the portal, and all of these files are accessible publicly. So that helped me to just right click on the portal, copy the whole HTML, and I placed it in qbank_html.html. So now this has all the links of the question papers that are necessary along with the HTML structure. And over this, I wrote a very small download papers program, and then all it does is it opens the HTML that I have, processes each row of the question paper, and while processing the row, it downloads the file into an output directory, and at the end of this download of papers, I will have all the question papers from the portal in my local disk. This is not the core aspect of our learning. This is just regular beautiful soup parsing. So I'll just run it and not step through it. So now you see that while I run it, it creates a question paper called folder, and then under this I have started to accumulate all the question papers from the question bank. The download process is complete, and now we have all the question papers under this folder called Q papers. So now that we have all this, I can start writing my AI agent. Now let us look at the agent code. The most important thing while talking to an agent is getting the prompt right. What kind of a prompt pattern you use becomes very important. Here I have used a few short prompt pattern. In the prompt, we give a few examples to the LLM to help it understand how it should construct the response back. Because I may have different forms of files, so I have given a few examples, like if the file name is like this, then give me back the subject extracted, the year, the exam, the type of the subject, whether it's a language or a course subject, type of the file itself, whether it's an answer key or a question paper, and similarly a few examples about it. And then I tell the LLM that you have to act as a file organizer, and then I ask it to give me a structured response. I instruct telling if the tool is available, then give me a tool response and don't return a valid JSON, otherwise return a valid JSON, and then what fields I need to have. This helps me to organize the files once the LLM responds back, and some normalization rules. So annual, final should be as annual, and then the language type, how do you arrive at what is the language type, how do you arrive at the language subjects, and then some abbreviations where it's helpful. So this helps us to arrive at a consistent naming at the end of it, otherwise we will still be left with scattered files and folders. I didn't want to be in the same situation where I started off with. Once I have the prompt with me, now on to the agent. So I'll explain the most important functions first, and then we will run through it. In the main, I get the list of files from this Q papers, and then for each file I send it to my agent. Organize file is the agent. So what does it do? First, it builds the first prompt by taking the prompt in our prompts py, replaces the file name, builds the message, and then hits the LLM. Chat is a function that I have written. We will dig into it. So it sends the message, and then it says, I need a tool because I have this organize file tool. That means build the arguments for it and give me the tool response. This is the first of T.A.O, thought T of T.A.O. The LLM sends back with the tool calls under tool calls of 0. I collect the tool call, I collect the arguments, and then I know organize file is the tool that I have written. And then I call organize files with the response that the LLM has given. And this helps me organize my file. And this is the action A of T.A.O. And once I have the result, for the final step, I again construct a message, tie all of this together with a tool call ID, and then send it back to the LLM. And now the LLM looks at the response that I have sent, and then it understands that, hey, this guy has executed the tool call correctly, and then replies back with a final answer. And this would complete the whole T.A.O of the agent. Now let us dig a little deeper into what is this chat doing and what is my tool organize file doing. Before we talk about this chat, I'll also talk about a few of the decisions we had to make. One is, which LLM do I talk to? So I use Deep Infra as the inference provider. And the second is the choice of model. I don't need a reasoning model here. I need an instruct model. I'm instructing the model how it has to do a job, and that is more than enough for me. And this is the API key with which I hit it. So the chat itself is a basic request call that I make. First, I construct the payload. In the payload, I say streaming is equal to false. I just want the response. It's a very small response. And then I also send my tools and the tools choice. We'll come to the tool quickly. And then I hit the request with a post request. I send my bearer token. I send the whole JSON payload and then wait for the response. Once the response comes, I return back choices of message. Now coming to the actual tool, the organize file, it collects all the data that the LLM sends and then builds the destination file, understands what is the source file name, and then copies it. Once it copies, I would also want to move those files into a processed directory so that I can stop and restart this program and it should not have an effect. Otherwise, every time it starts from the beginning. And if there is an error, I copy it to another directory called unprocessed so that I can look at it and understand why it really errored out. Now, along with writing the tool, I have to define the tool so that I can send this tool information to the LLM. Now, if you look at it, I say it's organized file because that's how I figure out what tool I have to call. I only have one tool, but it could as well be a list of tools, right? And then what are the properties that I'm expecting as an input to this? That means the LLM should help me extract these parameters. So now these are the moving parts of the code. Without further delay, let us run this. What I want to do is I want to step through line by line so that it helps us understand and reinforce what happens. So I will start a debugger point here and then trigger my debugger. Let us step through and figure out. It has got the list of files. It picked one of the files and then I call my agent. So in my agent, first we build the prompt based on the prompt that I have given, construct the messages object, say what is the role and what is the actual content. And then now I need to hit LLM. This is the first step of the thought T of T.A.O. Let's step into the chat just to understand how is it making the call. Construct the payload, which has the model name, the messages and the temperature. And I want the streaming to be false. Attach tools if there are tools, and I have a tool. And now I'm ready to make a call to the LLM. Attach the URL, attach the headers, attach the payload, set a timeout, and then make an actual call. Now the call is successful. The response.json has the actual response. Now that the thought is complete and I have a response, I now need to extract the tool call, extract the arguments. Now arguments has what I need to call with, and now I'll pass all of this to my action, that is organize of files. Let me step into this. In organize, I look at the data, construct the directory path where it has to go, construct the new name of the file, build the whole source path, get the destination path, regular file operations, use copy to copy them. And once I have finished it, because if the program stops in the middle, I want a way to start from where I left off. So once I have finished processing a file, I'll just move it into a directory called processed.dir. If there is an exception, I would move it into an unprocessed. So once I have successfully executed my action, now I need to build the message and send it back to the LLM to observe. While doing it, I also need to tie it with TC of ID, because that's how the LLM ties two tool calls together. And now call the LLM for one last time for observation. One last time for this file, but this happens over and over again for every file that we have. That's cool. It returned back, and then this function happens over and over again. Now if you look at it, out of my queue papers, it is removing every file, processing it, moving it to processed files, and then move it into the right organized structure, English, Hindi, Kannada. I will let it run and come back and show you the final output that I have. Cool. At the end of it all, I have all the files organized. My processed is full. It didn't create an unprocessed directory. That means all the files executed correctly. My question papers folder is empty. This is the state I want to be in. And once I finished this, I took all of this and uploaded it manually to the Google Drive so we can continue using it. So on the Google Drive, it shows up like this. Go into the math. There is this annual. Annual has all the question paper and answer paper. And similarly, if I go to any subject that is classified further, I get each of the question papers and answer papers all bunched up together. And that completes my 2 hours of Sunday, and my coffee has gone cold too. Hope this small AI agent should also give you some ideas about small AI agents that you can build to assist you in your day-to-day life. So for all of this, I spent less than $1, but then saved around 2 days of elapsed time, or 6 to 7 hours. And I fancy myself to believe my 7 hours was worth more than the $1 that I spent. Thank you for your time.